Alright, welcome back guys. So this is a sort of a support video for 3B, but it covers a lot of the same stuff we're going to look at in 3B. Okay, so it's kind of like an introduction. A lot of the material's the same, but I cover this section, or I go over these notes in my Math Reasoning with Support class, so I thought that this would perhaps be beneficial to you guys as well. Okay, so we're going to talk about something called scientific notation. Okay, so look at this little quote that I have here first. It says, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world." So this was supposedly said by a Greek mathematician or a Greek thinker whose name is Archimedes. Okay, you may have heard of him before. So he just meant that if he had a lever long enough, he could literally lift the world or lift the earth. Okay, and the reason I put this quote in here, guys, wasn't to demonstrate necessarily the power of using a lever. Okay, because you can use levers, and a fulcrum, which is like the pivot point, where you place that pivot point, determines how much force you can lift, or how much mass you can lift. But I put it in here to kind of demonstrate that, or to illustrate just how heavy the world is, or how massive the earth is. Okay? And having said that, if we try to represent the mass of the earth using kilograms, which is how it's commonly represented, or kilograms as opposed to pounds, it's a really large number. Okay, so I kind of put this in here to kind of segue into how do we deal with really large numbers. Okay, and in our everyday lives, guys, we don't really encounter numbers that are very large or very small for that matter. Okay, probably some of the largest numbers you might encounter is if you're watching the news and the U.S. debt is mentioned. Well, it's several trillion dollars. Okay, now a trillion is a relatively large number, but it's nowhere near as large as the mass of the earth. Okay, so scientific notation is a special way of writing numbers. It makes it easy to deal with big and really small numbers. Okay, so a big number could be like the mass of the earth in kilograms, and a really small number could be the mass of, say, an electron, or the mass of just an atom. Those are really small numbers. Okay, they have to be expressed with a decimal followed by a whole lot of zeros. Okay, all right, so let's remember what an exponential expression is. I know we've talked about powers of 10 previously. So an exponential expression, guys, you're going to have a base, which in this case is 10, and you're going to have an exponent. Okay. And what the exponent tells you is basically how many times you're multiplying the 10. So you would read this 10 to the third power. You could also say 10 cubed. And really this just means 10 times 10 times 10, okay, which is 1,000. So writing it as a power of 10 is just another way of expressing 1,000. And that's what we're going to look at. It turns out that any number, any big number, any small number, any number for that matter, can be expressed as a decimal followed by some power of 10. Okay? And we're going to look at an example right here. So it says, what if we want to write or express the number 700 using a power of 10 and an exponent? Okay, well, think about what is 700, or how could we express 700? Well, you could write it 7 times 100, okay? And 100 is a power of 10, meaning you can obtain 100 by multiplying some 10s together. Now, for 100, you only need to multiply 2 10s together. So then I could rewrite it like this. I could say, okay, instead of 7 times 100, I could write 7 times 10 times 10, because 10 times 10 is 100. And then furthermore, if I want to use scientific notation, I could say Well, this would then be 7 times 10 to the second power. Okay? So this right here is scientific notation. It's going to be some number between 1 and 10, and sometimes they'll have a decimal in it, followed by some power of 10. So that literally is what scientific notation is. Okay? And then the 700 is what we call standard or ordinary notation. And that's what we're more familiar with. Okay? So, in fact, your calculator, let me show you here real quick. Your calculator has a setting, if I come over here to mode, such that, see how it's got normal highlighted, but you can move it over here to scientific, and it would output all of those numbers in scientific notation, all those numbers that we're typically used to seeing in ordinary notation. So anyway, so scientific notation is a completely legitimate way to express numbers. And we use powers of 10 because we have a base 10 number system. Okay. It says when we work with really large or really small numbers, it's easier to use scientific notation to express those numbers instead of ordinary or standard notation. And this is why. So I actually looked this up and I put in here the mass of the Earth in kilograms. Okay. So if you recall from 2ABC when we were working with unit conversions, a kilogram, guys, is like 2.2 pounds. So it's a little more than twice as much as a pound. Okay, so look at this. I'm not even going to try to read this number using place values because it's got so many zeros. I would have to count and try to figure out what place values the 5, 9, and 7, and 2 are even in. Okay, but you can see this number in ordinary notation is huge, so you wouldn't want to have to write this out followed by all those zeros. So you can express it in scientific notation right here. So notice, to encapsulate all these zeros and the magnitude of this number, we use a power of 10, 10 to the 24th power. Okay? And then notice the 5, 9, 7, and 2, these all appear right here, but they appear as a decimal. So the way you actually do this is, this big number in ordinary notation has a little understood decimal at the very end. Okay? So what you do is you move this decimal all the way between the 5 and the 9, because you want the first number here to be between 1 and 10. So when I move the decimal right here, it makes it between 1 and 10. This becomes 5.972. And then you multiply by a power of 10. Well, that power of 10 depends on how many places you had to move this decimal point. So you could count them all up, guys, but evidently I moved it, or I would have to move it 24 places to get it over here between the 5 and the 9. So that's why this power is 24. Okay, so 5.972 times 10 to the 24th power is the same as, well, like I said, I'm not even sure how to say this. Okay. All right, so that's an example of expressing a really large number in scientific notation. Now, what about maybe a really small number? So, for example, the diameter of a human erythrocyte, which is just a fancy name for red blood cells. So you guys recall that red blood cells, those are the cells in your body. They're red, and they actually look like donuts if you were to look at one. But they're responsible for transporting oxygen throughout your body. They have a molecule called hemoglobin, which has iron in it, and it's what binds to oxygen. Okay, that process takes place in your lungs, and then those red blood cells get carried all throughout your body, and they give up that oxygen to all the cells. Okay, but anyway, a red blood cell is pretty small. This is how you would express its diameter in meters. Okay. All right. Now I will go ahead and show you how to convert this to scientific notation, and we'll look at formally how to do it. Okay. So what you do again is so the decimal point here is already written. So you're going to move it the opposite direction, and you're going to move it such that it goes between the 7 and the 5, because you want that first number to be between 1 and 10. So if I do this, I move it once, twice, 3 times, 4 times, 5 times, 6 times, right there. So that would put it between the 7 and the 5. So now it becomes 7.5 times 10. And then to figure out the power, it's going to be the number of times you move the decimal place. Well, I moved it 6 places, but I wasn't moving it to the left like I did over here. I was actually moving it to the right 6 places. And when that happens, you actually get a negative power of 10, okay? Because 10 to the negative 6th is the same as 1 over 10 to the positive 6. Which is the same as a 1 followed by 6 zeros, which is the same as a million. So 10 to the negative 6th is the same as 1 millionth. Okay? So we have 7.5 millionths of a meter here, essentially. Okay. All right, well, let's look at some other examples. Okay, so how does it work? So the number is written in 2 parts, kind of like I illustrated just a second ago. So you're going to adjust the digits with the decimal point placed after the first digit, followed by 10 to some power. That puts the decimal point where it should be. Okay? It shows how many places to move the decimal point. So here's an example. So this number, 5,326.6, you would have to move this decimal to the left 3 places to put it between the 5 and the 3. Okay? So now we have 5.3266. So see, this number is between 1 and 10. And then we say times 10 to the 3rd power, because you would have to move this 3 places to the left. Okay? And moving it to the left 3 places is really the same as multiplying it by 1,000, which is the same as 10 to the 3rd power. Okay? Sometimes, well, let me see here for a second. Oh, okay. Yeah, I'll mention what I was going to say here in just a minute. All right, so other ways of writing it with the calculator. Okay? So sometimes the calculator will give you an answer in scientific notation. So I'll give you an example. If I multiply let's say I have the number, 25, and I want to raise it to the 10th power. Well, if you multiply 25 by itself 10 times, that's going to be a really big number. And there's probably not going to be enough room right here in this row for the calculator to express that number. Whoops. I think my computer froze for a second. Okay, so what does the calculator do? It expresses it in scientific notation. So let me go ahead and hit enter here. Now look at that. Notice what it gives us is a number between 1 and 10, 9.53, and then some other digits. But notice this E in the 13. That E represents 10, and this 13 represents the power of 10. Okay, so 25 to the 10th power is 9.536743164 times 10 to the 13th power. Okay, in scientific notation. So, yeah. All right. So, yeah, this, if you want to express a power of 10 in the calculator, you just hit the power key. So if I want to say 10 to the 13th power, now again, 10 to the 13th power, it may not have enough room to write all those zeros, so it may just return the answer in this same form. Let's see. Yep, it does. Okay, it says 1 times 10 to the 13th power. So anyway. So 3 times 10 to the 4th power, this just means the same as, 3 times 10 to the 4th. Okay? This caret key means you're raising something to a power. And again, 10 to the 4th is just the same as 10 times 10 times 10 times 10, which in ordinary notation is 30,000. Okay, and like I said, the calculators often use a capital E. Sometimes they'll use a lower e, a lowercase e. Okay, so if you were to see something like this, 6 and then a capital E with a 5, that means 6 times 10 to the 5th power. Okay, or if you were to see this, 3.12 and then a capital E and a 4, that means 3.12 times 10 to the 4th power. Okay, and then 10 to the 4th power is the same as 10 times 10 times 10 times 10. Okay, so in ordinary notation, this would be 31,200. Alright, so how to do it? Well, we've already talked about this sum, but this will formalize it. Okay, so to figure out the power of 10, think about how many places do I move the decimal point. Okay. Alright, so for example, let's say we have this number, 327,000. Now we want to write it in scientific notation. Well, the decimal point is understood to be at the very end, okay, because it's not written in here. So it's understood to be at the very end. So you've got to move it all the way between the 3 and the 2, okay, to make it 3.27, because this number has to be between 1 and 10. And then you think, okay, well, how many places did I move it? Well, I moved it 5 places. So this has to become 10 to the 5th power. Okay? So when you're moving the decimal point to the left, you're going to need a positive power. Now, similarly, what if we had a very small number that we wanted to write in scientific notation? Well, in this case, the decimal's already in here. So I would move it 1, 2, 3 places to the right, and that would put it between the 2 5s. So we'd get 5.5. But now we're moving the decimal in the opposite direction. So that's when we use a negative exponent. Okay, so I moved it to the right 3 places, so that power of 10 becomes negative 3. Now, sometimes students will try to think, well, or they'll forget, I can't remember, when to move it, or excuse me, when I get a positive exponent or when I get a negative exponent. Well, I'll look at it like this. I'm starting out with this big number, 327,000. Initially, it becomes 3.27, which is a really small number, which means I need to multiply it by a big power of 10, okay, to offset that change. So I use a positive exponent. Now let's contrast this with the second example. So we start out with this really small number. We make it bigger when we turn it into a 5.5. Okay? So to offset making it bigger, this power of 10 needs to be smaller. So that's when we use that negative exponent, or that negative 3. So that's the way I think about it. And that way I don't have to think about when do I move it to the left, or excuse me, I don't have to think about when do I need a positive exponent versus when do I need a negative exponent. I think about it as, do I need this power of 10 to be bigger, or do I need it to be smaller? Initially, did my number go from big to small? And if so, I need my power of 10 to be big. Or did my number go from small to large, and I need my power of 10 to be smaller? Okay? So try to think about it that way if you can, guys, or just refer back to your notes here. Okay? All right. So this says, after putting the number in scientific notation, check that the digits part is between 1 and 10. Okay? So it can be 1, but it can never be 10. The reason it can't be 10 is because if it's 10, that means you would have another power that you could add to that power of 10. And then the power part shows exactly how many places to move that decimal point. Okay? So now we're going to talk about going in reverse. So what if we're given a number expressed in scientific notation, and we want to write it in ordinary notation. How could we do that? Well, it's just the opposite process, okay? So you're going to start out with this number, 4. Now 4 doesn't have a decimal, but we know it has one understood to be behind the 4. Okay, so really this is like 4.0. Okay, so I'm going to go ahead and write it, 4 with the decimal point. Now this exponent is telling me where to move it. Okay, well, this negative exponent means my number needs to get smaller, so I need to move it to the left. Okay, you can also come up here and think about it. You know, if you were going in reverse right here, this negative exponent is going to have to move that decimal to the left to put it back where it started. Okay, so when you see a negative exponent, that means that the 4 or your number over here needs to get smaller. So I'm going to move it to the left 6 places. So you just start counting 1 place, 2 places, 3 places, 4 places, 5 places, 6 places. So that puts me right there. And so all those empty places I'm going to fill in with zeros. Okay? And so my answer is going to be 0.5 zeros followed by a 4. Okay? And it's always a good practice, guys, to keep a 0 in front of your decimal point. Okay. All right, I think we've got one more in this section. And then the next video, I'll do some more examples using scientific notation. More examples like you're going to see in your homework, okay, for 3B. And there's also a video link right here that I show my face-to-face classes. So what I may do is I may put a link to this video in below this video so that you guys will also have access to this. Now you can watch it if you printed out the notes, you printed these notes out, and you got the Word file, you can click on it that way. But anyway, okay, so let's look at this one. Now this one's different. We've got our 6.2, but now we're multiplying it by 10 to the 5th power. Well, 10 to the 5th power is big, so I need to make this number bigger, which means I need to move that decimal to the right to make it bigger. Okay. So that's 6.2, I need to move that decimal to the right 5 times. So 1, 2, 3, 4, 5. Now I've got to fill in those empty places with zeros, okay? So now the decimal is at the very end, and if it's at the very end, we don't actually have to rewrite it. So this is going to become 620,000, I believe, in ordinary notation. Yeah, that's right. Okay. So just be thinking about it like this. If you got 6.2 and you're going to multiply by 10 to the 5th, well, that's a big number. So to make 6.2 a big number, you move the decimal to the right. That makes it turn into 620,000. And then in the previous example, we've got 4.0, and 10 to the negative 6 is a really small number. So to make 4.0 a really small number, you got to move it to the left. Okay, remember, moving a decimal to the left makes it small, makes the number small. Moving a decimal to the right makes the number big. Okay. All right, guys. Well, I guess that's it for this little piece, and then I'll do another video in which I'll work out some more examples. And it turns out you can do arithmetic with numbers that are written in scientific notation. Okay, so if you remember from elementary school how you learn to add, subtract, multiply, and divide, numbers that are written in ordinary notation, well, you can perform all those same operations with numbers expressed in scientific notation. And we're going to look at how to do that. Okay. All right, so I'll see you in the next one.